I'm Anil Kumar, and in this video we'll try to understand how to find quadratic equation from x-intercept. The question here is find equation of a parabola shown in the graph below. Now this is a very typical graph, different from others which we have taken. Here we have only one x-intercept. Now the question is, given one x-intercept, how can you find the equation? Generally we had been using the formula y equals to a times x minus x1 times x minus x2, where x1 and x2 were two x-intercepts. And using a third point, which was the y-intercept, or which is the y-intercept in this case, we can actually find the equation. So here we only know one x-intercept, and that is at x equals to 1. So it is 1, 0. And we can also read y-intercept, which is 0 minus 2. Now the question for you is, since we have only one x-intercept, do we need another point to find the equation of this quadratic function? Think about it. Or you can actually find the equation and then look into my suggestions. Okay. Now what we notice is that if there is a turning point at the x-intercept, that means both the roots are at one point. Correct? So we say here, since there is a turning point, so that's kind of an important note. Turning point at x-intercept. It means that the order of this 0 is 2. That means there are two, that means we have two intercepts. I should actually say roots or zeros at the same point. We normally refer this to be as multiplicity or order of 0. That is a better term to be known. Since at x-intercept the y value is 0, so the x-intercept could be treated as a 0, correct? Now there is a difference between the two, and therefore zeros have order of multiplicity. So if there is a turning point on a graph at the x-intercept, then it means that the order is more than 1, it is even. So in this case, since we are talking about parabola, it is 2, right? So that is a key thing. Therefore, we can now write the equation as y equals to a times x minus, one value of x-intercept is at 1 whole square. Since there are actually two zeros at the same point, that is the reason why it is turning. The previous examples which you saw with two x-intercepts, there the graph was either crossing like a line, do you understand, was like this, or kind of like this, do you understand, where it just crosses. In this case it turns, and therefore there are two x-intercepts at the same point, and that's the reason for such cases we actually write equation as y equals to a times x minus x1 square, right? Because both x1 and x2 are equal. Both are at the same point. That's the reason, right? So I want this point to be very clear to you, and at times we will refer to this point with a 0 of order 2 or multiplicity 2. I hope that's clear, right? Now, we can, at this stage, we can use one other point, which is y-intercept, to find the value of a, correct? So we'll do likewise. So to find a, we'll use 0 and minus 2. That means y is minus 2 and 0 for x, square. So that gives us a equals to minus 2, right? Now we can write on the equation y equals to minus 2 x minus 1 whole square. I hope you got the idea, right? So what we learned in this video is that turning point is a result turning point at x-intercept. I should write at x-intercept. Turning point at x-intercept is a result of two zeros. That is kind of very important to understand, right? Therefore, we have square x minus 1 whole square, or we could say x minus 1 times x minus 1, correct? So that's the concept which I wanted to communicate, and I hope that's clear. Let me know if you have any doubts about it. Thank you and all the best.